Welcome to Solar Tech Talk, where we nerd out about solar and renewable energy technology and policy. I'm Aaron Bingham, Product Manager with BayWa RE.
And I'm Tiernay Marsh, Sales Manager at BayWa RE.
Tierney, there has been a lot happening the last few months. I guess it's only been weeks, so I'm saying months. We've seen some really big actions on NEM in the last few weeks that we wanted to start off with.
Yeah, as you know, as a lot of our listeners are aware, there's been a lot of targeted action at NEM across the country this year, and especially in California, where NEM 3.0 is really coming under fire. There have been a number of utility actions in place to try to come up with that next step of what NEM would look like. And it's getting some pushback from CalSA and others. Aaron, what's the latest on that?
Yeah, so there's been a new proposed decision that's been released by the California Public Utilities Commission regarding net energy metering in its third iteration, so to speak. There were a lot of changes that were proposed in the last round of this step, where there was a proposal made by the CPUC that included a lot of fees for solar customers and a lot of other things. It really made any PV installation energy storage installations pay back a lot worse. The new proposed decision got rid of a lot of the fees that were in the first round, but they still have cut down the average export rate compensation for, solar customers who are able to send any power back out onto the grid by approximately 75%, according to some reporting that we saw from Solar Building Magazine. And this is a huge cut that dramatically reduces payback for customers, and it increases risk associated with these installations.
Yeah, I have to say that would be a bummer for our industry if that was passed, even if some of the specific fees that were originally proposed for solar users have been taken out of this proposal.
Yeah, the way that CalSA talks about it, this proposal compared to the first one is of course better, but the first one was unquestionably bad, and this one is just more moderately bad than the first one. So, it's improvement in increments, but there's still a really important conversation that folks need to make sure that they're participating both in California and around the country around net energy metering policies that are being proposed by their utilities in their local areas. This is going to have a huge impact on the PV installation market, especially the residential PV installation market. And there's a lot of expectation that if passed in its currently proposed format, NEM 3.0 in California would be a serious drag on California's adoption of solar technology en masse.
Right. Yeah. So I think there's a pretty strong call to action here, and I think we're getting maybe a little redundant about it, but CalSA has been one of the organizations at the forefront of this charge in terms of making sure that solar and storage is available to people, specifically in California. But as we know, and as we've talked about, California is often the first domino in some policy changes. So get involved, check out to see what CalSA's up to. You can check out their website, and they have a specific page on net energy metering, and that's at calssa.org/NEM action.
Yeah, that's a great place to go if you're looking to participate in the conversation in California. There are some great articles, if you're interested in learning more, that were published in Solar Builder Magazine in the last couple of weeks here. One is 5 takeaways from California's NEM 3.0 remix, published on November 11th. And then there's another article in Solar Builder Magazine that was published on November 10th titled California Revised NEM 3.0 Decision Removes Fees but Cuts Average Export Rates by 75%. And that article has a great breakdown of some of the changes in this latest proposed decision that everyone should be aware of and be able to speak to and understand how it's going to impact their business.
And if you're not in California, there's some other articles that might point you in the right direction in terms of what's happening in your state. Energy Toolbase came out with one recently called Solar Net Energy Metering Tariffs Are Under Threat Nationwide. So go and check that out at their website.
All right. Yeah, this is an important space for us to be keeping an eye on. Another topic that I think is on everyone's mind in the industry is what are the impacts going to be of the Inflation Reduction Act? I know that I've seen questions bubble up from the sales team over here at BayWa around the domestic content requirements and which manufacturers are in a position to meet those. That's still an open question because as of the time of the recording of this episode, we haven't received the guidance from the IRS that we would need to start to parse out what those requirements are and who's going to be able to meet them.
So we're going to be chatting more about the Inflation Reduction Act here in December, and hopefully we'll be able to answer some of those burning questions that people have about domestic content and domestic manufacturing. That makes me think of a conversation you and I recently had, Aaron, with JA Solar. They're one of the top manufacturers globally, I would say, and they are looking at those questions right now. Shall we jump over to our conversation with Thomas and Tosho at JA?
All right, let's do that. And, anyone who just started hearing from their BayWa sales rep about JA's residential product line is going to be really interested to hear some of the points that come up in our conversation. So let's jump right in. All right, we're joined by Thomas Nielsen, Director of Sales over at JA Solar, and by Tosho Galitev, Senior Engineering Support Manager at the JA Solar team.
Thanks, everybody. Happy to be here.
Thank you.
Yeah. So can you give us a brief history of JA and where they stand in the PV marketplace?
Sure. Happy to do that. Yeah. So hello to everybody out there. My name is Thomas. I've been with JA since November 2015. So coming up on 7 years this month. At the time when I joined, JA was moving about 75 megawatts of product into the US market. Prior to building modules, JA actually started as a cell manufacturer, and it has been and was heavy on the R&D front. And a lot of the cell production went into a lot of the names that we're familiar with in the market today. JA transitioned to module production probably around 2010, 2011, I want to say, and slowly grew the business. It's a conservative company. That trend in conservative nature has continued, and I'll kind of touch on that a little bit. But its position in the U.S. market and globally has grown significantly. From 75 megawatts in 2014 or 2015, I guess it was, the company is now moving about 2 gigawatts into the U.S. market.
Wow.
Next year, we'll move about 4 gigawatts, and that will be with JA-owned production facilities in Vietnam, where we manufacture the ingot, the wafer, the cell, and the module, using US-made polysilicon from Hemlock out of Michigan. JA's global capacity is around 60 gigawatts. So the company has really grown and secured a position, and I would say the top 5, probably the top 3 suppliers globally, and our position in the US market in utility, commercial, residential, and distribution continues to grow. We've got some more to do, I think, on the distribution front, but we're definitely getting there.
Yeah, and we've been partnered with y'all for a very long time, historically, primarily working with you to provide commercial modules for our customers, modules that are generally geared towards larger projects. And that's been a super fruitful partnership. But recently, we started offering residential modules as well. Can you tell us a little bit about how that shift came about for your team and what's kind of driving your strategy there?
Yeah, the industry kind of went from the 158 millimeter size cell to the 166 and is now moving to the 182 and the 210 millimeter cell. JA had its manufacturing of 158 millimeter cells in Malaysia, and we essentially kind of leapfrogged the 166 to the 182. So I would say that we were a little behind the market in terms of product offering of that mid 350 level product for a while. The market's now transitioned to a larger format, the 182 millimeter, which is a 390, 395, heading to a 400 watt product. And so now with JA having a size and a format that is competitive with the market, with a really good supply chain, with all JA owned from ingot to module in Vietnam with US polysilicon supply, means that we're really well positioned to provide modules to the market, modules that are competitive, modules that have a really competitive supply chain for kind of the current policy environment in the US and requirements for the US market. And so that means that we're kind of ready to start to service the residential market with a product that it wants. And that is at the kind of the tip of the spear in terms of standard efficiency or slightly higher efficiency product. And we've kind of spent a number of years establishing our base as a supplier to utility players in the market. And we've worked with all the leading EPCs and developers in the market. We've got a really strong portfolio of product in both utility and commercial. And we have kind of entered the residential space with making sure that we're working with the key residential players so that we're on the AVLs that we need to be on. And now we want to really tap into this partnership that we've had with BayWa for a long time to make sure that we are addressing the mid and the long tail and a lot of the regional installers that typically work with distribution to, increase Jay's share of market in the residential space through BayWa. With this product, which we think is ready and well suited to what you guys are trying to do.
Yeah, we've definitely seen a lot of those long tail customers really excited about this product and starting to adopt it in a big way. So that's really awesome to hear that you guys are putting that at the top of your priority list. One of the things that I was curious about is that this is a larger wafer, so that's kind of impacted the module design. Can you speak to that at all?
Yeah, I think I'll probably have Tosho chime in a little bit, but I mean, the increasing size of the wafer is kind of a somewhat of a normal progression in terms of the way the modules develop in terms of efficiency. So we've seen kind of this step from the 158 to the 156 to the 182. We also see 210 in the market. JA and a number of other manufacturers have kind of settled on the 182 millimeter and feel that that's kind of the size that is optimized for modules. We could see in a couple of years that the market shifts to maybe the 210 or a larger format, but I think we'll also see other technology improvements before we maybe go to a larger wafer, for example, the gapless technology or TopCon or something like that. But Tosho, just to throw the ball to you for a sec, is there something specific that's driving JA and much of the industry to a larger wafer size and hence a larger cell size, or is that just kind of like a natural progression?
Hello, everybody. Thank you, Thomas. So the bigger wafer is a natural progression of the product itself. Since the wafer growing industry could make larger surface wafers, which making the product cheaper and more affordable, we can utilize those wafers and make larger solar cells. So the solar cell technology has not changed substantially from 2-3 years ago, but the size of it has changed. So if you think of in terms of current and voltage is very similar to what we had before. For the amount of solar cells we have in the module, the current has gone up, so that the result is a much higher power output of that module for a certain specific amount of cells. But if you think about it, the surface of the module has become bigger, so that's how we get the higher power. But it is a very natural progression, and like Thomas is saying, it is evolving towards gapless, it is evolving towards different types of interconnecting the solar cell, and of course the even larger wafer, which could be utilized at 210 millimeters, which JA at the moment has no plans for it, but in the future we do not know.
And to that, I would add that our ingot and wafer facility is capable of producing 210 size wafers and cells, and our module lines are capable of manufacturing modules with 210 millimeter wafer and cells. But again, we've settled on 182 as kind of the optimum size.
There are some disadvantages for the 210, of course. being the higher current, because the larger surface of the solar cell results in a very, very high current, which actually creates some problems in terms of system management and wire management, managing losses. That's why you would see modules, the solar cell not cut in half, but even cut into 3 pieces, actually. Some even cut in 4. So that's
the way to control the current from each cell.
Current. Yep. Yeah. The current is directly proportional to the size of the cell itself, to the surface area. So that's how you would reduce your current. Yeah.
That's great. And now our customers will be really excited to hear about the optimization that you guys are doing in the background.
Yeah, absolutely. And one of the things that I know kind of comes up as cell size increases are concerns about fragility and things of that nature. Do you have any comments that you'd share with folks, as they're making their own product decisions around something with, say, like more of an M6 cell size compared to an M10 cell size? Have you all done tests to determine if there are any concerns on that front?
We have done quite a lot of testing. JA is one of the companies which has an internal testing labs and testing. We have a product research department which is relatively large, and there's quite a lot of testing going on. We also do a lot of testing in the US using third-party labs like PVAL and RTC. We see better product performance from the larger solar cell in terms of that it is greatly improved from in the interconnection of the solar cells between them. So we now have 11 bus bars. We used to have 9, and it all started with 2, then 3, then 4, then 5, and then we went to the multi-bus bar product.
Yeah, you can kind of tell how long it's been in the industry depending on how many bus bars were common when you started, right?
Yeah, it's that. And
our version of tree rings, right?
Yeah, I actually remember the 5-inch solar cell. I've actually seen 4-inch solar cells, which is we're now 6, 7, 8. So in terms of performance, these newer modules are much better. And in order to keep the product in line with the wattage and the size of the module, we have actually reduced the number of solar cells in the module. So a similar module with 158 solar cell would be 60 cell module. Now we are with the 182 millimeter wafer, we are at 54 cell module. So the size of that module is reduced, but the wattage is actually higher than the 60 cell module. I don't know if that makes sense, but it's actually
totally makes sense.
A better performing module. We also have, with the new designs, we're using gallium doped wafers, which actually have extremely low LID effect, light-induced degradation in the initial stages. It's pretty negligible, and long-term performance of the module. If you look at our warranty progression, we have been able to reduce our warranty degradation slightly for the life of the product, which is 25 years, or that's the warranted life. It will work much more, of course, because there's nothing moving. 25 years for single glass and 30 years for double glass products, basically, in general, warranty for JA.
That's great. So what types of things should folks know when they're designing a project with the S31 series?
It is a 54 cell module. So you would expect to have the voltage comparable to a 54 cell module. So the voltage levels will be slightly lower than a 60 cell module. That's one of the things they should be watching. So when they're going in and checking their voltage of the module, they should not be confused by the slightly lower voltage or thinking that there's an issue with the module. The current is increased. The current is increased. So using, if you're connecting your modules into a serial string, so daising the notch, you would need to have a number 12 at least in order to make your string. If you need to number 10, of course, for longer runs, then yes. The fuse size has also changed. That's for the string. It is a bigger fuse size. It's 25 amps, used to be 20. Everything else is pretty much the same. There's no new secret, basically. One of the things which JA did, one of the advantages of the module is the holes on the frame are the same for almost all series of modules. So we have a 54 cell module, we have 60 cell modules, which we don't sell here, but we can make. We have 66 cell modules, we have 72 cell modules and 78 cell modules. So the mounting holes of all of those modules, they're pretty much the same. And so the distance between the holes from centered, they're the same. So we have 1200, 1400, and 400 millimeter holes, basically. So you can utilize those holes to mount the module on a rail, or clamping actually would be very similar to an older type module. However, you have to remember that given the size of the modules are slightly bigger. So you will have to pay special attention to the maximum loading of that module. And depending on the requirements, building department requirements for that area, you might need to have a better support, so the modules don't float. We still have the standard 5400 pascals down and 2400 pascals up, but that's your loading of the module. So the module doesn't float in the air. It has to be supported. So it's actually the support will really drive how much the module can carry. Like you mentioned, actually, the short rail support. Short rails, we have reduced the short rail. It's actually not the strength, but the flange on the bottom. So there's no more, you can no longer bolt the flange. There's nothing to bolt there. You can only clamp it on the top. And we typically don't recommend it, because when you start clamping on the short side, your loading gets reduced dramatically. But if that's what the project calls for, and if the loading agrees with the design, then it's no problem to clamp it on the short side, as long as you're not overloading it. That's the bottom line, basically. With 54 cell module, it's more square and it's more user-friendly in terms of you will feel higher surface area. You can easily do the surface area than big long piece, which is rectangular, which you might have issues. So
that's a very comprehensive overview of what folks should be keeping in mind. That's fantastic. Thank you.
You're welcome. Sorry.
No. that's why we asked you all on. This is great.
I sometimes keep on going, and that's why we have Thomas to stop me.
Thank you so much, Tosho, for that comprehensive overview.
You're welcome.
So Thomas, I know that you and I have been working together with a lot of customers to try to get them converted over to JA. We've had some success, which is exciting. Can you speak a little bit to what the availability looks like going forward? Right now, of course, we've got a lot of product in stock, which is exciting, especially the 395 series. But what should we be looking at in terms of 2023?
BayWa has put its POs in well into 2023, so we have production allocated to BayWa. I don't anticipate there being an availability issue on that front. The residential market seems like it's potentially softening a little bit due to interest rates in terms of demand. I think that'll be more of a short and shallow dip, and then demand will pick up again. But the utility segment is really hot for next year. We have committed most of our production already for 2023 for the commercial and utility side of the business. And that, of course, impacts overall supply. That could well come into play for other suppliers as well. So in the residential space, we exist with the utility space. And when we think about capacity and supply of the U.S. market, we think in terms of production lines for the U.S. market. Every production line is around 35 megawatts. Mm-hmm. So we don't really produce a line and a half. We either produce a line or we produce two. So we're either talking about, for JA, for example, 35 megs of availability per month or 70 megs of availability per month. And if there's enough demand, then we bump up to a second line. So that's something we kind of need to manage and talk about and work with you guys on what the overall demand portfolio looks like. But I think the short summary of that is the residential may be getting soft a little bit. Let's not let that lull us into complacency. It makes sense for both BayWa and its customers to make sure that you kind of have your supply secure through first half well into 2023. The standard kind of output right now is a 395 watt, and we'll see that start to progress towards a 400 watt, I think, in Q2. And then we'll see that shift over Q2, Q3 to probably a 395, 400 mix, maybe even trending a little faster towards a 400, 405. That depends somewhat on production line efficiencies and so forth. But that's kind of, as we look towards 2023 and into 2024, that's generally where the product is headed. The product that we're sending to BayWa now is the product that BayWa and your customers will receive throughout 2023. I don't think there'll be any major design changes. The next kind of design change on the horizon is a gapless product where we kind of just move the cells close together. I think that'll likely be sometime in 2024 where we see that. But overall, I think supply is good. For 2023, it's as we talked about, really solid supply chain for the US market, competitive product. So everything is kind of lining up well on that front.
Yeah, I think we kind of just briefly touched on it earlier that you all have a supply chain that's dependent on hemlock for your polysilicon raw materials. Do you want to expand a little bit on what the benefits are of that relationship and that arrangement and how that impacts your customers downstream?
Yeah, there is recent laws on the book regarding the content of modules. There are content requirements for the US market, and there are potentially many different ways that can be fulfilled. There's certain areas of the world where companies should not be bringing silicon in or other componentries because of the law on the US books and for humanitarian reasons and so forth. The JA, as I mentioned early on, is a conservative company. So we fortunately have a supply relationship with Hemlock, which is a U.S. provider of polysilicon. That polysilicon is manufactured in Michigan. It's shipped to Vietnam, where we make it into an ingot, into a wafer, into a cell, into a module. That is, from our perspective, the absolutely safest approach we can take for sending product to the U.S. market that will not get held or will not get held for an extended period of time by customs CBP. It doesn't mean that it can't be held. And if folks are familiar with the law and the way CBP works, then we as a supplier and as an importer to the U.S. market need to provide documentation that confirms the sourcing of that product, which we can do. We can provide that level of traceability. We're very confident in our supply chain, and we are fully comfortable with that supply chain, the product that we're bringing in being fully compliant. Having U.S. polysilicon is the best risk mitigation for JA, for BayWa, for your customers in terms of product getting held and maybe even getting sent out of the U.S. market. None of our product is going to get sent back out onto a boat across the sea out of the U.S. market. It's all compliant, and we have the documentation to prove that. So for customers who are aware of the law, who want stability of supply, who want to ensure that their product doesn't get held up at the ports, doesn't get held up by CBP. If you're looking for risk mitigation, then JA has hands down amongst the Asian manufacturers the best supply chain for the US market. And that's really kind of what it's about in terms of the polysilicon content. A, risk mitigation. B, from a marketing standpoint, and something that I think your customers would want to talk to with their customers about, is that a certain percentage of this product is US based, 30% or whatever it is. So we actually need to start putting a little American flag or something like that on our data sheets to indicate that it's a global product. There is a U.S. supply base, U.S. worker base that's going into the JA product in advance of setting up module assembly or cell assembly here, for example, cell production here.
JA has been really strong. You've been able to maintain strong reliability the past several months at a time when many other suppliers have struggled or run into bottlenecks with the import process. So I think that's a testament to the risk mitigation that you're doing with Hemlock, and just wanted to say thank you for that.
Yeah, awesome.
It's our pleasure. We sleep well at night as well. We
touched a little bit on, what's coming down the pipeline in the more immediate sense in the next year or two. But looking further out, I'm sure folks have, seen articles about all different kinds of exciting solar tech, things like TopCon, or I can never quite say this right. Is it perovskite? I don't know, Tosho, if you want to correct me there.
Yeah, that's the solar cell technology, basically. The TOPCon, the heterojunction perovskite crystals. Basically, you would have different technologies of how to make the solar cell. And the solar cell, when you're building a solar cell, you have basically layers to create the semiconductor on top of the silicon wafer and on the bottom. So you have different technologies, which some of them yield high efficiency, but higher price also. We at JA, we have been experimenting with most of those technologies. Like I mentioned before, we have a R&D department, which is rather large, and they like to play with stuff. We have been experimenting with the TOPCon technology. We have been experimenting with the heterojunction. We are excited about the TOPCon technology, basically, which is a PERC solar cell. At the moment, currently, all of our solar cells are PERCed. So that would mean that we do use a P-type silicon wafer, which is actually created into a PERC-type solar cell. We are planning on continuing improvement to go to an N-type silicon wafer. That would be probably sometimes in 2024, late 2024. And after transitioning to an N-type wafer, we would be going to a TOPCon wafer, which is a type of PERC also, which slightly improves the efficiency of the solar cell. The heterojunction solar cells, even though they're high efficient, we do not see them as being able to mass produce them. So JA, being a very large company, we mass produce all the solar cells. All of the solar cells are the same. We make only one type of solar cell at the moment, which is the JAP type PERC solar cell. We do not have different types. So that would continue to be true, and making that many solar cells, that many gigawatts of solar cells is very, very difficult with heterojunction solar cells.
So thank you, Tosho, for telling us about what's on the horizon in terms of the next technology that you guys are jumping into. Thomas, can you speak to any other broad plans that you have in the next couple of years? Hint, 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 domestic production?
Yeah, happy to talk about that. Well, I mean, I think, as we touched upon earlier, Jay's presence in the U.S. market continues to grow, right? We've moved from 75 megs annually to 1.3 to 2 this year to 4 gigawatts next year. The next kind of big thing on the horizon, I think, due to the Infrastructure Reduction Act, Inflation Reduction Act, is U.S. production. There's a number of manufacturers that are looking at this, and Jay has plans on that front as well. And so we're targeting getting started with a facility sometime in mid 2024, I think, or second half of 2024, to tap into the incentives in that legislation. And we'll probably start with 1 to 2 gigawatts with the ability to expand. Highly likely that we're producing both commercial utility and residential for the U.S. market. And then we have the ability to expand that to maybe 3 to 4 gigawatts. We might contemplate wafer or cell manufacturing in the U.S., although doing that is more complicated. There's increased energy demand, water needs, et cetera. So not an easy step to take, but moduling is fairly straightforward, and we have plans to introduce module production to the U.S. market sometime in 2024.
Well, that's really exciting to hear. And I know it's something that our installers will be really excited about too.
Yeah, it's just one of many ways that we're really aligned with you guys and very excited about the future. You guys are just such a fantastic partner, and it's a real pleasure to get to work with you.
Thank you. Yeah.
So Thomas, Tosho, thank you so much for joining us for the Solar Tech Talk. It's been a pleasure.
Thank you so much.
Thanks for the call today.
Wow, it was great talking with Tosho and Thomas, huh?
Those fellows are fantastic. I've worked with them both for many years now, and it's really exciting to see how their team has grown and how their company has grown in a way that really aligns well with what BayWa is all about.
I agree. And I have to say, I really enjoyed learning more about how they're looking at the future of solar technology and what their plans are. That's really exciting stuff. So I want to highlight really quick that we do have oodles of JA modules. So if that's something that you're interested, reach out to your sales rep, check the web store. We've got tons of JA 390s and 395s in warehouses across the country that are available right now to stick on a roof somewhere.
Absolutely. And we're hoping to be back in everyone's feed next month with an episode about the impacts of the Inflation Reduction Act as we predict them in 2023. And we'll also hopefully bring everyone a little bit of a retrospect on everything that happened in 2022. It was a super crazy year, and we're excited to just kind of take a look back and see everything that was accomplished.
Yeah. What's the use of riding the solar coaster if you can't look back and enjoy it?
I know, right?
Well, Aaron, lovely chatting with you as always, and I'll talk to you in December.
Yeah, sounds good. I'll see you at the metaphorical little photo booth that has our pictures as we were going down that big first hill. You know?
Yeah, I'll see you then.